there will be like mostly of conventional power resources like thermal power plant or hydro or nuclear, those kinds of power plants nowadays, like due to the increased like incoming of wind and solar. So there is the power generation is getting more complex, and also like there is a more requirement for refurbishment or replacement, or new substations has to be built, and the existing substation has to be implemented with newer like equipments. So this is also one of the challenge, increasing demand on refurbishment. and and there is also a demand for like cost and time pressure when compared to the like previous decade or previous 1 or 2 decades. So we have to complete this any particular project in as quickly as possible and with lower cost as much as possible, and more flexible use. So we are demanding more flexible use of the assets like a transformer or transmission line, and the availability and reliability of the power system has been increased. The increased expectation on transmission system availability and reliability. So since we have increased demand for electricity, and the reliability requirement has also been increased for if we have like hospitals or defense applications or airports, such kind of like important applications. So the power should be it should be available as a like uninterrupted power. So if it is if you go back like 20 or 30 years back, so it doesn't matter like if we have a power cut for 3 or 4 hours per day. But today this is not the case. So everybody is like expecting both the industry and other sectors are expecting a reliable power supply, and also ease of operating. So ease of since we have more technologically advanced applications in substation, we still demand ease of operating for maintenance personnel. So it is not always that engineers will be present to operate the substation equipments. So it also has to be easier for the operating personnel to operate the substation equipments. So these are all some of the challenges, and this has been addressed by digital substation, and we will see about how we are going to address these demands. And we will have a short quiz just for introducing coming up to understand the terms which we frequently use in our whenever you go through a technical article related to power systems or substations, you will be frequently coming across these terms. So we will go to the answers directly. So these are all the some of the terms which you will come across frequently: International Electrical and Electronics Engineers Association, International Electrotechnical Commission, CT for current transformer, VT for voltage transformer, AS for air insulated substation, GS for gas insulated substation, fiber optic cable and fiber optic current sensor. And I'll go to one more similar abbreviation. So these are also some of the technical terms which you will come across, like SCADA, SAS, AVR, AGC. We will go to the answers directly. So if you know the answers also, you can just post it in the chat box. So anyway, so SCADA is for supervisory control and data acquisition, and this SCADA it is mostly related to process industries like cement plants or steel plants. When we go for substation applications, so this SAS, substation automation system, it is also much similar to that of the SCADA. But for dedicated substation application, we call it a substation automation system. For other areas like steel plants or cement plants, we call it as a SCADA. And automatic voltage regulator and automatic generation controller. So these will be used in the generation plants. And the single line diagram, flexible AC transmission system, megavolt ampere, photovoltaic solar, remote terminal unit. So these are all some of the abbreviations which you will come across. So we will first see about the introduction to introduction and brief explanation about what a substation is, and we will understand what are all the components which we use in a substation, and then we will compare it with the future trend of the digital substation. So first we will see about our what a general substation is. So a substation in a power system is a place where electric power is transformed to a lower voltage or to a higher voltage. We can convert a voltage to a lower voltage or to a higher voltage. In case of transmission, in case of long distance transmission, the voltage will be stepped up to a higher value. The voltage will be stepped up to a higher value from generating plants, and then to the load center, and then towards the load center, the voltage will be it will be transformed to a lower voltage for its distribution, 11 kV or 33 kV distribution. It will be transformed to a lower voltage, and these voltage stepped up and step down operation, it will be performed in a substation. It will be performed in a substation, and this substation will contain various equipments. So we will see about the equipments. So this is nothing but the general concept of a substation. This substation is a place where the voltage is stepped up or stepped down. So, and we have various equipments like transformers, circuit breakers, and other equipments. So we will go to the this part directly. So this is the SLD of a substation. SLD is nothing but your single line diagram. All the three phases, we will not be drawing all the three phases like R, Y, B to represent an equipment. Since this is anyway, if it is going to be a three-phase balance system, we will assume it as a single line or a single phase or a single line, just for representing in a diagrammatic format for ease of drawing and for ease of understanding. So the image which you see here, this is an SLD of a substation, and we have these are some of the major equipments which we every substation has. Even if you have visited any substation across India or any substation across the world, this will be the standard. And so the major equipments bus bars, and this is the place where the sources and loads will be connected. And from bus bar, we will be having a disconnector, and we will be having a circuit breaker, and then current transformer. So this is the current transformer, and we will have a voltage transformer, and we will have earthing switch, and we will also have a surge arrestor. And these equipments has their own purpose. So we will see about these equipments in a detailed manner now. So first, bus bar. So it is a term we use for main bar or conductor carrying an electric current to which sources and loads are connected. So this is an image of the bus bar. So here, from here only, all the sources will be connected. So here it is a three-phase. It is a three-phase system, and we have one bar for each phases. And this will be supported by an insulator. This will be supported by an insulating medium, and all the sources will be connected to through a circuit breaker. So the supply will be coming to the circuit breaker, and all the each phases will be having a breaker. So for three phase, we have three circuit breakers, and whenever we close the circuit breaker, so this supply will be coming to this bus bar. This supply will be coming to this bus bar, and so there are various types of bus bars. So this is it is a bus bar in an air insulated substation, and we have a disconnector, and we have disconnector. So we will see the major difference between disconnector and circuit breaker. Disconnector and circuit breaker. Disconnector, it is also called as an isolator. We can also call it as an isolator, and we also have a circuit breaker. So both the equipments are like a kind of a switch, and there is an important difference between both the switches. There is an important difference between disconnector and circuit breaker, and we will be seeing the difference in a table. I have tabulated some of the points for isolator and breaker, so we will see this. So this is an image of the disconnecting switch or isolator. So there will be two contacts. There will be a moving contact and a fixed contact. So this is like a fixed contact, and this is a moving contact. So whenever we want to open this isolator, this contact will move apart, and for closing, it will move towards this fixed contact. We have a circuit breaker. So circuit breaker, it is used to interrupt the circuit while current is flowing through them. So circuit breaker, it is used to interrupt the circuit whenever the current is flowing through them. And circuit breaker is the equipment which will it is used to trip the equipment whenever there is a fault. And there are various types of circuit breakers which you might have came across, like oil type circuit breaker, and vacuum circuit breaker, and SF6 gas circuit breaker. So there are various types of circuit breakers are available. Even the MCB, which we use in for low voltage 14-volt applications in our households for 3-phase 14 or single phase 230. It is also a miniature model. It is also a miniature model. Even that is called as a miniature circuit breaker. And this is a high voltage circuit breaker. And we have 3 poles. We call it as a 3-pole circuit breaker. For each phase, we will be having a single pole. And this is a box which is used to control the operation for opening and closing operation. Operating mechanism panel. From the signals will be received from the control panel, the control room, which we saw in one of our the first slide, and from that control panel we will be receiving the control signal for opening and closing of the circuit breaker. And we also have a position indicator. And this will indicate whether the circuit breaker is open or closed. And we have the mechanism rod. This is a mechanism rod or a transmission rod, and this is used to perform the closing and opening operation. So we have the motorized control operation, and this will operate this rod for performing closing and opening of the circuit breaker. And this operation can be controlled from our control room or SCADA. So it can be controlled in a remote. We no need to go to the field to operate this circuit breaker. And similarly for the isolator will also be quite similar. The operation will be quite similar to that of the circuit breaker. And we will be having a current transformer. So the main application of current transformer, if it is a low voltage system like 14-volt system or a single phase 230-volt system, we will be having an energy meter which will be connected directly to the supply, so that we can measure the current for to measure the amount of units consumed or the energy consumed. But in case of a high voltage substation, we will not be able to measure the current. If it is high voltages 33 kV or 110 kV, we have various voltage ranges, 230 kV, 400 kV. So in case of such high voltage substations, we will not be able to directly measure the current. So we need a mechanism for stepping down the current. So that particular equipment is called as a current transformer. So current transformers are used with ammeters. So the current will be stepped down to a lower value first using the current transformer, and then it will be given to the ammeter for measuring the current. And similarly, we can give the current for watt meter, power factor meter. So and also for protection relays. So current transformers will be connected in series with the line. So this is an image of the current transformer. So and this is a cross-sectional view. So here we will be having like this the high voltage system. The high voltage system will be connected here, and the incoming current will be connected here, and it will flow through the current transformer, and the current will be from here. It will go as an output. And this will be actually like the internal mechanism. If we see here, so internal mechanism if we see here, we will be taking this the high current to the bottom, so to the bottom area, and from there we will be having a core. We will be having a core, and this will like convert this like high current to a lower value. So here we have a terminal box, and from this terminal box, like we will be able to access the current. So for example, if we have a 1000 ampere here, and this will be proportionally converted to 1 ampere. It will become converted to 1 ampere. If it is like the primary side is carrying 1000 ampere, we will be having like in secondary we will be having 1 ampere. If the primary is carrying 500 ampere, we will be having 0.5 ampere. So proportionally we will be getting a secondary current, and this secondary current will be connected to energy meters and protection relays. And then similarly, voltage transformer, similar to that of the current transformer. So we cannot measure the high voltage directly. We cannot measure the high voltage directly. So we need a voltage transformer to step down the voltage. This is an image for the voltage transformer. So similar to that of the current transformer, this voltage will be stepped down to a lower value, and we will be like accessing the lower voltage in this terminal box, and this will be connected to the the meters and protection relays. And earthing switch. So we have earthing switch for like whenever if we want to take maintenance of a substation. And this any particular equipment which we want to take maintenance will be earthed. So since the substation it will be like in operation for a long time, so there will be some due to the induction and due to like the spill there will be storage of the residual flux will be present in this particular equipment. So we will be earthing that equipment for in order to safely to work on that equipment. The main purpose of the earthing switch, it is intended to protect people working on the equipment during maintenance. And we will be having surge arrestor. So surge arrestor is a device used to provide necessary path to ground for surge voltage or voltage rise happening due to lightning. So whenever there is a lightning in which is stuck in the transmission line, there will be the voltage in the transmission line will get increased. So in order to prevent like damage of the equipment due to high voltage, we will be providing a surge arrestor which will they bypass the extra voltage to the ground, so that other equipments will not get affected due to the high voltage. So surge arresters, they do not operate during normal condition. If we have a normal voltage, during the normal voltage condition, this surge arrestor will not bypass the voltage to the ground. Only when there is a voltage rise because of lightning, this particular over voltage will be bypassed to the ground. So this is an image of the surge arrestor. And we also have overhead ground wire. So this is an image of the overhead ground wire or shield wire. So normally, like we will be having like if you have seen the transmission lines, we will be having the transmission lines which will be supported by the insulators. So normally we will be having like 3 phases, but here it is represented as an like a single phase. But normally we will be having 3 phase lines, and above the tower, at the top of the tower, we will be having like a shielding wire. We will be having a shielding wire, And this shielding wire, it is used to protect the phase conductors. It is used to protect the phase conductors from lightning. It is used to protect the phase conductors from lightning. So that is the reason why it is placed at the top of the transmission line. This line does not carry any power. Only the phase conductors, it will be carrying the power. And whenever there is a lightning, this will be bypassed to the ground. So it will receive the lightning and it will bypass to the ground. At the middle, the healthy phase conductors, they will not get affected. So again, I'm coming to this SLD. So these are all the equipments which we have seen now, the bus bar, disconnector, circuit breaker, current transformer, and voltage transformer, earthing switch, and surge arrestor. So we have had a basic idea about the application of all these equipments. So if anyone has any doubt, we can you can just ask your if you have any doubts. If you have any doubts about these equipments, you can just ask. Otherwise, we can go to the next part. My voice is audible, right? Can someone confirm? Is my voice audible? Hello, sir. Can you confirm? Hello. Hello.
Yes, you are audible, sir.
Yeah. Thank you, sir. Thank you. Okay. So actually, there are two types of substation. So this is an example for AIS substation, air insulated substation, and this is an image for GIS substation, gas insulated substation. So in air insulated substation, the most of the substation which you might have seen across the across the city, or the substation which you have seen outdoor, it is of AIS substation. The reason why we call AIS substation is there won't be any insulating medium between the phase conductors. There won't be any insulated medium between these phase conductors. So here, if you see, all the equipments will be it will be placed in the outdoor, and there won't be any insulating medium between these phase conductors. So if you see these conductors, there is no insulated medium, and that is the reason why we call it as a air insulated substation. And we have a GIS substation, or a gas insulated substation. And in gas insulated substation, the conductors, the phase conductors, or the current carrying conductors, it will be placed inside a medium which has a gas. So for example, if you see here, we have two RYB. See, if you see here, there are 6 conductors. For example, if it is an RYB, and again we have RY and B. So totally there are 6 connectors, 2 RYB phases, two 3-phase systems are there, and this is a cylindrical pipe, or a cylindrical tube, and inside the inside the middle of this tube there will be the conductors will be placed, and this tube will be containing gas, which is SF6, or sulfur hexafluoride. This SF6 gas will be providing insulation property. It will provide insulation property so that the high voltage conductor will not flash over. So for example, it is a 400 kV substation. So even though this is a high voltage 400 kV substation, we could see that all the conductors are placed very close. All the conductors are placed very close. The reason is that we have provided insulation using gas. So even if you see here, so it is very compact. It is very compact. And if you have visited metro stations, there is a gas insulated substation near Alandur, and there is a gas insulated substation like Coimbatore metro station also. So for the areas which have very high population, and we do not, if we do not find like larger area for like the outdoor kind of substation, mostly in metro cities, they will go for this gas insulated substation. This will occupy only very less area, and we can place all the equipments very, very closely. So if you see here, the control panel is here, and all the like equipments like breaker, isolator, it will be very, very compact when compared to that of the AIS substation. So since there is only air insulated medium, so we have to place all the equipments apart so that there won't be any flashover or flex interference. So we now from here we will be moving into like the digital substation. So we have seen the equipments. We have seen the equipments which are all used in the substation, and we have also got some idea about each of the equipments used in the substation. Now we will see like how we are going to digitalize these equipments. Like which of the following equipments can be digitalized? So we have seen some of the equipments like transmission line, transformer, CT, VT, bus bar, protection relays. You will see it again. Communication equipment, signal cabling. So you can just you can just voice out, or you can just give your answers in the chat box. So which of the following equipments can be digitalized? All the equipments can be digitalized, or only few of the equipments can be digitalized? You can just give your answers. Okay. So you will go to the the next part. So these equipments cannot be digitalized, like transmission line, transformer, bus bar, insulator, and again circuit breaker. I have not mentioned, but circuit breaker. These kind of equipments cannot be digitalized. These are all the physical equipments which we need physically to transmit the power. We need transmission line, we need transformer, we need the bus bars, we need insulators, we need circuit breakers. So we cannot digitalize these equipments. It is they are needed physically for transmitting the power, but these equipments can be digitalized. These equipments can be digitalized, like protection relays, current transformers, voltage transformers, communication equipments, the SCADA equipments, signal cables. These are the equipments can be digitalized. Although we call it as a digital substation, only these equipments will be like these equipments can be digitalized. But we still need transmission line and like a transformer, those kind of physical equipments for converting the power and transmitting the power. So here is an example. Like of like analog telephone exchange in early 1960s, before 1960s and 70s. So like even though like this is a like a telecommunication system, so they were using like the contact multiplication relays. They were using the physical equipments are used extensively, like for switching the telephone lines, and the signals will be transmitted in the form of a signal. There is a difference between like a data and there is a and the signal. The signal will be it will be transmitted in the form of an electrical signal, like 24 volt or 48 volt. Even if you have seen the olden days landline telephones, it will be transmitted in the wire. It will be the signals will be transmitted in the wire, and it will be there will be some voltage like 24 volt or 48 volt in this wire. So, and they have occupied a very large area. And in modern telecommunication system, all our like the voice signals, it is transmitted in the form of a data. It is transmitted in the form of data or wireless information. So like similar to this, even in our modern digital substation, only the electronic equipments or the communication equipments can be digitalized. So this is like one of the example how like the olden day telecommunication system has been converted as a digital. And viewing like this digitalization, now we are moving towards like we call it as industry 4.0, and presently we are in industry 3.0, and most of the process has been computerized. Most of the process are using automation system, and they are computerized, and they are also continuously like they are integrated. They are continuously getting integrated. We are connecting different equipments for operating for operational ease. And now we are moving towards industry 4.0, and this connectivity is enabling the computerization, and connectivity is enabling more visibility to understand the entire process, and more transparency, and to more predictability for more autonomous operation, for more unmanned operation. So this is a evolution of substation. So we have three different substations, and this is a conventional substation. This is a conventional substation which we are using more than less than 5% of the substations, like 5 or 10% of the substation are conventional substation, and about 90% of substation are in this are modern substation which we use. And digital substations are very rare, less than 0.5% or 0.1%. And we have not yet moved to digital completely. We have not yet moved to digital completely. Currently, we are in this stage. And previously we were in a conventional kind of substation. And we will see what is the major difference between the previous kind of substation which we are using, and the present one and the future one. So there is not much difference between the switch gears. There is not much difference between the switch gears which were used previously and the switch gears which we use currently, like the circuit breakers, CT, PT, isolator, and everything. They were quite same. And the major difference comes here. So if you see, so we will be having a CT and PT, and these will be it will be given to the protection relays and metering equipments. Earlier we were using electromechanical relays for protection, and currently we have moved to digital relays. That is the major difference between the previous and the present substations. And we also have the control board for controlling the operation of the substation equipments. And again, here we have a SCADA. We have SCADA, and it has been completely computerized. It has been completely computerized, and it is performed it will be performed from a computer. We will be having an industrial computer, and the SLDs will be displayed in the screen. And we will be able to control the operation of the various equipments in the substation. So this is the major difference between the previous conventional substation and the present substation. So previously we are not having much capability for SCADA, and also we were using electromechanical relays previously. And presently we are having very good advanced technologies for SCADA, and we have digital relays. And we are using a protocol called IEC 61850, and this protocol is used for communicating the protection relays and the SCADA. And it is used to communicate the protection relays and the SCADA. And we use Ethernet cables or fiber optic cables, RJ45 cables for this communication. But previously we were using copper cables only. We were using copper cables for between electromechanical relays and the control board. And also for the signal from the CT and PT, we are also using the copper cables. And when we go to the digital substation, so there is a very significant or important changes in the substation equipments also. So comparatively, if you see here, so there is not much difference between the conventional substation and modern substation, present day substation. But in the future, we are going to use non-conventional instrument transformers instead of the present day CT and VT. and this will it will occupy very less area. This non-conventional instrument transformers or optical current transformers or optical voltage transformer, it is like a sensor. It is like a sensor, and these sensors will occupy a very less area. So that is the reason why it occupies very less area when compared to this the present day substation. So almost the space requirement has been reduced here, and the when we use non-conventional instrument digital or non-conventional instrument transformers. And for transmitting the signals from here, and for transmitting the current and voltage signals to the protection relays, we need protection relays for the protecting the equipments like transformers and bus bar. So we have various protections over current protection, over voltage, under voltage protection, differential protection, and everything. So you might have came across these protections. And we need current and voltage signals for this protection, and also for metering also we need the current and voltage signals. So in order to provide the current and voltage signals, we are using the 61850 protocol, which in turn uses fiber optic cables and RJ45 cables. So these current and voltages, it will be transmitted to the protection relays in the form of data. It will be transmitted in the form of data. But here in our present day substation, we are transmitting the current and voltages using copper cables, not using fiber optic cables. We are using copper cables between CTPT to the protection and control equipments, and this will be sent as a signal. This will be sent as a voltage signal or current signal. And here in digital substation, it will be sent as a data. So there is a major difference between signal and data. In signal, it will contain some voltages or minimum voltages like 4 to 20 milliamps or 1 volt system or 5 volt system. It will be the signals will be sent as electrical signals. But here it will be sent as a data, similar to that of our the internet email or WhatsApp message. We receive this as a data. So similar to that, it will be sent as a, for example, if you are measuring 1 ampere current, it will be sent as a message. It will be sent as a message that this particular CT is measuring 1 ampere. Or if we are measuring 10 volt or 100 volt, this voltage transformer sends the data to the protection IED that this particular VT is measuring 100 volt or 10 volt. So this will receive a message. It will be received in the form of a message, and this is the protocol which we use for digital substation 61850. And again, for SCADA applications, again similar to that of our present day applications, so we are using 61850. In present day application, we are using the 61850 only for SCADA applications, from relay to the SCADA, but not for CT to the relay. So there are two interfaces, like CTPT to the relay and relay to the SCADA. There are two interfaces, CTPT to the relay and relay to the SCADA. So CTPT to relays are still we are using copper cables, but in digital substation we are using the 61850 for CTPT to relays and relays to the SCADA. So this is about the digital substation. So if you have any doubt, you can just ask. So we will see a small introduction about the protection relays. So earlier we were using electromechanical relays. And their application has almost ended around 1980s or 1990s. And then we were using solid state relays. And nowadays we are using numerical relays or digital relays. We are using numerical relays or digital relays from around late 1990s. We are using numerical relays. So most of the substations which we see now are they are using numerical relays. So this is an electromechanical relay. So the most of the concept which we study theoretically in our power system papers, they explain the concept of the electromechanical relays. So although we are not using this electromechanical relays now, so less than 5% of the relays are electromechanical relays. Very few relays are electromechanical nowadays. But still, like the understanding the concept using this electromechanical is important for going forward to other advanced protection relays. So these kind of amplitude comparators, balanced beam amplitude comparator, these concepts you might have came across in the power system protection papers. But we are not using, at present we are not using this electromechanical relays. And then we moved from electromechanical relays, we moved to solid state relays around till even 1990s. They were using solid state relays, and they contain diodes and triodes, electronic components like diode, triodes, FET and BJT. So compared to the electromechanical relays, they occupy less area, and more advancement is possible using the solid state relay. And then we move to numerical relays. This is the present day relays. They are completely digitalized, and they contain microprocessor. It is an industrial computer. It is an industrial computer which has the capability more storage capability and processing capability, RAM and ROM capability. Everything is there. So it is an industrial computer. It is an industrial computer. So we call it as numerical relays, or we call it as IED. We call it generally in industry we call it as IEDs, intelligent electronic device. We call this as intelligent electronic device. And they use the hardware it is based on embedded and microprocessor system. So hope you could understand the difference between the solid state relays, which is using diodes, triodes, and these kind of transistor equipments, and the difference between the relays which we use microprocessors. So this is one of the example of the digital relay. So it is the model which is manufactured by a company called ABB. And so if you see here, so this is the front interface area, or HMI, or human machine interface. So we will be able to give the settings to this relay. We have navigation buttons which we can use to give settings to the relay, and we can also program the SLD in this in the relay. We can able to program the SLD, what is the particular equipment which is used to which is connected, and the current carrying capability and the voltage of the substation. Everything it can be programmed. But this is not the case with solid state relay or electromechanical relay. We cannot we do not have this kind of programming capability. That is the reason why we are moving towards these digital relays nowadays. And we have these indications. We like light emitting diodes. We have this indication lamps, light emitting diodes, and we have various signals. So we will be able to identify whenever there is a fault or mal-operation. So this will display an LED. And if you see here, we have an RJ45 port. So if you have so most of your laptops will be having this RJ45 port or LAN port for accessing the internet. And this is the port which we call it as an Ethernet port, or IEC 61850 port. And so similarly, we will be having these kinds of port in the rear side, in the back side. If you see, so this is the rear side of this particular IED. So we will be having various communication capabilities here. So this will be an it will be an ordering option. Whenever we are going to order a relay or purchase a relay, we can have a RJ45 port or fiber optic port. So here we have a fiber optic port. Actually, in a fiber optic port, there will be two ports for we call it as TX and RX. One will be for transmission and one will be for receiving, and we have various set of ports. So this is again the HMI. This is again the HMI, and the every equipment which we are used in the substation, it can be drawn as drawn in the HMI, and we will be able to monitor and we will be able to get the feedbacks of these equipments on the status of the equipment, the closing status or opening status. we will be able to get it in the digital in the display itself. And we have like the measurements, events, disturbance records. So whenever the normal operating operations like opening and closing, it will be recorded as an event, and the fault like overcurrent operation or differential protection operations, it will be recorded as a disturbance. Whenever there is a fault, this relay will record it as a disturbance. And we have protection settings, and we have diagnostics and testings options also. So even this particular, whenever this particular relay itself it is getting malfunction or fail, we will be able to get the particular fault in the display itself. So we have like various embedded modules inside this relay. We have a binary input module, output module, and various other milliamps module. So you might have heard about this milliamps, 4 to 20 milliamps or 0 to 20 milliamps transducers or sensor inputs. So we can get this it will be this relay will be able to get these inputs from the field. So we have this capability. And we can also give the output, binary outputs for giving command. We can give the command to operate a circuit breaker, the command to operate an isolator. So it will be this output will be used to operate an isolator or a breaker. So again, this is an simplified outline when compared to conventional substation and digital substation. Yes, you have seen we are using the transmission line, towers, transformers, and everything in the conventional substation, which is again we are using the same kind of equipments. The only difference which happens is for transmitting the signals to the control room, for transmitting the signals to the control room from the switch yard. Earlier we were using copper cables. But now we have started using fiber optic cable. We are started using fiber optic cable, and the signal it is transmitted as a data. And the size of the equipments which is used in the control room also reduced. So this is the major difference between the conventional substation and the digital substation. And by reducing the number of cables, we will be using thousands of cables. And there are also we will be using a lot of protection relays. When compared to digital substation, the number of cables also reduced, and also the number of protection equipments, it is also getting reduced. So ultimately, we are saving the cost. Using digital substation. So this is an overall layout of a digital substation. So we have a transformer. We have the non-conventional instrument transformers optical CT and optical VT, and all these equipments will be connected using this IEC 61850 protocol. So transformers, CTPT, and circuit breakers, isolators, everything will be connected, and these and the status of these equipments and the operation, everything will be transmitted in the form of a data. So here we have this control room. So from here we will be able to understand the status of the equipments, and also we will be able to give command to operate the equipments, to switch on or switch off. So we will go to benefits of this digital substation. So reduce substation footprint. Footprint is nothing but the number of we call it as carbon footprint. The amount of carbon dioxide released for manufacturing the particular equipment. Since the number of equipments it is also getting reduced, the number of carbon dioxide released for the manufacturing particular equipments it is also reduced. And interoperability, we will be able to interoperate various digital relays. We can use various types of manufacturers in the same substation. And reduced copper cabling, as we have seen before, we are reducing the copper cables and we are replacing it with fiber optic cables, and it is easy to configure. And maximum reliability and availability, and real-time performance, and smart grid communication capability, and reduced cost of ownership. So these are all some of the important benefits of substation. And again, so this is for conventional substation and digital substation, we are saving the reduction in copper cable by 80% in digital substation. And the number of equipments required is also reduced in the digital substation when compared to conventional substation. And it is again the number of equipments. It is also the space is also reduced in digital substation. And we are using the non-conventional substation, which is again reducing the space requirement when compared to conventional substation. In conventional substation, like we are using disconnector, CT, and again we are using disconnector. So this is like a circuit breaker. But when we go for digital substation, all these equipments, disconnectors, CT, and breaker, it can be combined in a single module. So if you see this red color, this equipment, circuit breaker with integrated optical CT and disconnecting function. So this will integrate all these functions. So this is because this the optical CT, it will occupy very less area. So that is the reason why it can be integrated into a single equipment. And the shorter installation time, so it will take very less time for installation, and the shorter outage time. So digital substation will it is comparatively much reliable compared to the conventional substation. And operational cost. So this will also it will have less operating cost when compared to conventional substation. So these are all the digital. These are all the advantages of the digital substation, reduced cost, outage timing is reduced, shorter installation time, and shorter space requirement. This is also a shorter space requirement, less number of equipments requirement, and a reduction in copper cables. So we will see about optical current transformers. So first we will see some introduction to some electrical effects. So we have come across the equipments like generators, motors, and transformers. And the operating principle of these equipments, it will depend upon the electrical effects, which can be like electromechanical effect or electromagnetic effect. And we also have one more phenomenon, which is electrochemical effect. Just a minute. Sorry for the interruption. So we will start. So these are all some of the electrical effects when related to the electromagnetic, electromechanical, and electrochemical. So here in battery, whenever we are storing charge in the battery, electrical energy is converted to a chemical energy, and whenever when we take the charges from the battery, the chemical energy is converted into electrical energy. And similarly for generator and motors, in generator the mechanical energy is converted into electrical energy, and in motor, electrical energy is converted into mechanical energy. And this interaction is taking place using flux, whether if it is a generator or motor or transformer. we have magnetic effect. So that is the reason why I have mentioned both electromagnetic and electromechanical in these equipments, and electrochemical and battery. And there is also something called as electro-optic effect or optoelectric effect. So this is the basic principle for the current transformer. The non-conventional current transformer it is working on the like principle of electro-optic effect. So FOCS, it is nothing but fiber optic current sensor. We call it as a fiber optic current sensor. So this is the current carrying conductor. This is the current carrying conductor. What we will be doing is like we will be having a light source. So here the electrical signals, it will be converted as a light. It will be converted as a light, and this light will be transmitted in an optical fiber. So you might have seen this optical fiber. You might have seen this optical fiber in even like nowadays, like this cable TVs, they are using this optical fiber for transmitting the signals. So here in optical fiber, we will be converting the signals in the form of light, and this optical fiber will be carrying the light, and we have a retarder and mirror mechanism, and this light will be circulated around the conductor. This light will be circulated around around the current carrying conductor using the optical fiber, and there will be interaction between the, so whenever there is a current carrying conductor, whenever a conductor is carrying a current, there will be flux present around this conductor. There will be flux present around this conductor, and this flux will interact with the light which is carried, and there it will create some phase difference in the light signal sent, and this mirror will reflect these changes, and we will again receive this light which will be transmitted using this fiber optic cable, and based on the like phase shift, we will be able to identify the magnitude of the current flowing this conductor. So this is the like the original signal which is sent. So here if you see the arrow mark, this is the signal which we send to the to the current carrying conductor, and this is the signal which is reflected using this mirror, which is again received to this source. So after receiving this like reflected light, we could see that there is a like phase difference. There is a phase difference between the lights, and this optical phase shift is proportional to the to any instantaneous value of the primary current. So it is proportional to the primary current. Whenever there is a increase in current, this phase angle difference will increase. Whenever there is a reduction in current, this phase angle difference will reduce. So based on this measuring the phase difference, we will be able to measure the current which is carried in this primary conductor. This is the major advancement in the fiber optic current sensor. So if you see here, we have the three phase conductors R, Y, and B. So we have this retarder and mirror arrangement, which will circulate the light here, and again the reflected light will be received, and it will be it will be received and it will be processed using the digital signal processing unit. So, and based on the phase differences, we will be able to measure the current which is carried in this conductor. So this is an example again for redundant or backup kind of signal processing unit. So here we have, in previous case, we saw that there is only one processing unit is there, but here we have two processing units. Even though like even any one of the processing unit fails, or any one of the optical fiber fails, we will still be using the other one, which can be used to measure the current which is carried in this conductor. So this is again the image which we saw earlier. So we have the light source which will be sending the light, and we have a retarder and mirror arrangement which will circulate the light, and it will reflect the light and send back to the light source. So, and we will have a phase difference here. So this is the light which is sent, and this is the light which is received, and we will have a difference between phase difference between the light sources. So if you see here, So there is no phase difference between the green and the purple color light source. So both will be there will be a 90-degree. It is an orthogonal light, but there is there from the starting point there is no phase difference. But if you consider here the light which is received, it will contain some phase difference. So this is how the measuring this phase difference, we will be able to measure the magnitude of the current. So every current carrying conductor, it will produce a magnetic field, and this magnetic field will interfere with the light. So that is the reason why this magnetic field created due to this current, it is also causing a phase difference in the light. So that is the reason why we call it as a optoelectric effect or electro-optic effect. So this is a conventional current transformer for 245 kV. So see the size of the the modern day fiber optic current sensor is reduced when compared to the previous one. And whenever we go for a higher voltage, for example, it is a 245 kV. And whenever we go for further higher voltage in 800 kV, the size is almost reduced to half. The size is almost reduced to half. So this is the reason why the modern digital substation will occupy very less area when compared to the equipments used in the conventional substation. So again, so these are all the advantages. Space, there is no space constraint, shorter delivery time, high flexibility, interoperability, and safety. So here I want to explain what is the meaning of interoperability and safety. So interoperability, for example, if we consider a general example of smartphones. So most of the smartphones we have USB chargers, which can be used for any most of the smartphones like Samsung or Nokia. We can use the same USB chargers. And even the headsets or the headphones, we can use the same headsets or the headphones for laptops and most of the mobile phones. So that is nothing but interoperability. We can use the same equipments which we can use to connect other equipments. For example, in case of digital substation sense, we have various manufacturers like ABB, Siemens, General Electric, Alstom, so Schneider Electric. These are all some of the companies which manufacture protection relays and power system equipments. These equipments will be able to interoperate. We can connect even though they are manufactured by different manufacturers, we can still interconnect them. So that is the meaning of interoperability. And when we are coming to safety, so we saw that earlier we are using signals in the form of voltage signal and current signal. Now we are using data. So in case of when we use signals, we will be working with the voltage and current signals in the relays. But when we are using data, we will be working with fiber optic cables. So there is no danger of electric shock. So that is the reason why the point of safety is also mentioned here. So, earlier we saw that we saw various equipments like isolators, breakers, transformers. So we saw various substation equipments. Now we will see how our how we have to perform an operation in substation. And for performing this operation, how our digital substation is enabling to reduce the cost and for a better operation. We will have a small real-time example. So this is a bus bar. We have a double bus bar arrangement. And we have a generator here. We have a generator. So this is a physical equipment, and this is a symbol for generator. And we have a transformer. So this is the physical equipment, and this is the symbol for transformer. And let us consider this as a load. We consider this as a load. And this X, it is a circuit breaker. And this is a circuit breaker. And the line, this horizontal line, this is an disconnector or isolator. This is a disconnector or isolator. So these are all the primary equipments, and we will see a small real-time operation about these equipments. So for example, here we have isolator. We have an isolator at the top for line A, and we have an isolator at the bottom for line B, and we have a circuit breaker. For example, if we consider all the equipments are open, all the both the isolators are open, and also the circuit breaker is also open. For example, if we want to connect line A and line B, if we want to connect line A and line B, we have to close all these three equipments. We want to close both the isolators, and we also want to close a circuit breaker. So can someone say what is the sequence of operation? Which equipments has to be closed first, and which equipment has to be closed at the last? You can give an answer for this. Which equipments we will close first, and which we will close last? Don't worry, even if we get wrong, it doesn't matter. Anyway, we will be seeing the answers. So you can just give your opinion. Doesn't mean that you have to give the right answer, but you can just give a try. Okay, we will move to the next part. What we will do is, first we will be closing the isolators. We will close the isolator of line A, and at second we will close the isolator of line B, and at last we will be closing the circuit breaker. So we will see why we are closing the circuit breaker at the last. So this is the comparison between isolator and circuit breaker. So isolator, it can be operated only during offload. And circuit breakers can be operated both during on-load and also off-load. So the reason why we are using why we are operating isolator in off-load is the braking capacity of isolator is very, very less. The braking capacity of isolator is very, very less, and the braking capacity of circuit breaker is high. So that is the reason why circuit breaker, it can be operated during on-load and off-load, but isolator, it can be operated only during off-load, and the braking capacity of isolator is very, very less. So for example, first, if we have closed this isolator and this circuit breaker, and then at last if we are closing this isolator, since the braking capacity of this isolator is less and this is an offload switch, when we close this isolator, there will be arcing in this isolator, and this arcing will damage this isolator. But by keeping the circuit breaker open, when we close this isolator, there won't be any problem. Since the circuit breaker is open, there won't be any current flow between line A and line B. Since the circuit breaker is open, there won't be any current flow. We can directly close the isolator, and then we can also close this isolator of line B also. So there won't be any current flow between line A and line B since the circuit breaker is open. And at last we can close this circuit breaker. And since the circuit breaker braking capacity is high, braking capacity of circuit breaker is high, and it can be closed in on load, so it will interrupt the arc. Even though there might be arc, it will interrupt the arc, and it will not damage the circuit breaker. So this is the basic operating sequence. Whenever we want to close two lines, like line A and line B. First we will close both the isolators, and at last we will close the circuit breaker in on line. By closing the circuit breaker, we will be directly connecting line A and line B. Hope you could understand this. So if you have any doubt, you can just ask. So by using this, we will perform a small real-time operation. So for example, we saw that we saw a small SLD. Now this red color, the red color bus bar and the red color equipments, it is an energized condition. It is an energized condition, and they are carrying power. And the bus bar and the equipments, it is in black color. It is not energized, and they do not have any power. So now, so now we have like two bus bars. We have bus bar at the top and bus bar at the bottom. So the bus bar at the top, it doesn't have any supply. It is de-energized. It doesn't have any supply. And the bus bar in the red color, it is energized. So here it is a generator. We have a generator. It will generate the power, and we have a transformer. It will step up the voltage, and then we have a like isolator breaker. Everything is closed, and we are supplying the supply to the bus bar, and from the bus bar we are taking the load. So this is the load. So if you see this arrow mark, the power is flowing like this. So for example, if we want to take maintenance of this bus bar, so here we have a bus bar. This at the bottom, we want to take maintenance of this bus bar. So we want to connect it to the other bus bar, the bus bar at the top. So this is how a substation look like, and this is how we perform the switching operation in a substation. We will see how we are performing a switching operation in a substation. So first, as you saw before, first we want to close the isolators. First we want to close the isolators, right? We will close the isolators. Sure. So we will close the isolator first, and again we will close the second isolator, and third we will close the breaker. So X mark is the breaker. We will close the breaker at the third. After closing this, the supply from the bottom, it will be transmitted to the other bus bar. So from here, the energized bus bar, red color bus bar, the supply will be transmitted to the other bus bar. So now this bus bar is also energized. So now this bus bar is also energized, and now we can close the other two isolators also. We will close the other two isolators also. We can close the other two isolators also. By closing this isolator, we are having two parallel paths. We are having two parallel paths from generator to breaker. Sorry, generator to load. So from here, it will go to the transformer, and you take this path. You can go to this bus bar, top bus bar, and again it will come like this. Otherwise, we can go to the other bottom bus bar also. We have two parallel paths. We have got two parallel paths. So now both the bus bars are energized. Now both the bus bars are energized, and our objective is to isolate the bottom bus bar. So earlier only the bottom bus bar was energized. The top one was not energized. Now we are closing isolator and we are energizing both. And now we are opening this isolator related to the bottom bus bar. We are opening the isolator related to the bottom bus bar, and here we will be open. The next sequence we will be opening the breaker. So we will open the breaker 8, and again in 9th operation we will open the isolator, and in 10th operation we will open the other isolator. So now the bottom bus bar is de-energized, and the bottom bus bar is de-energized. And there is no interruption, between the generating source and the load. The power is continuously flowing. So this is how the in everyday life, there are a lot of switching operations which is happening across the substation, across your city, or across your country, across your state. There are a lot of switching operations which is happening across our country, but we are getting uninterrupted supply. We are getting uninterrupted supply. So this is how a switching operation is performed. This doesn't cause any interruption to the loads. So still the generation will be supplying power to the loads without any interruption. So now we have performed a small operation. And for performing this operation, so we need the signals. We need the signals of the all the equipments. We need the open status, closed status of all the equipments, which has to be provided to the protection relay. So this is the protection control panel. All the signals will be provided in the wiring. For example, the open status of the H switch, we need a wiring, and for closed status of H switch, we need a wiring, and open status of line isolator, closed status of line isolator, open status of breaker, closed status of breaker, and open status of bus isolator, closed status of bus isolator, Similarly, for all the feeders in the substation, we need various signals, and these signals will be like sent in the form of copper cable. So this will increase the cost. But so this is how present day substation looks like, and we have we call it as a protection and control drawing or a secondary drawing. And using this drawing, we will refer this wirings. So this will have a larger impact on the cost and the complexity. But whenever we go for a digital substation for this interlocks, so this is again the cabling, which will create like a lot of confusion in physical wiring. But whenever we go for a digital substation, we use signals, call it as like goose. We call it as a generic object oriented substation event. So it will be transmitted in the form of digital signals. It will be transmitted in the form of data in the fiber optic cables, so that we will reduce a lot of cost of this the copper cables, and also the complexity of these like wiring is also reduced. And there are also a lot of switching operations for which we need the status of various equipments. And there is a protocol, we call it as IEC 61830, which is used to define the this object-oriented signals, similar to that of your object-oriented programming kind of things. We have an object-oriented signal. We call this as an goose, which is nothing but your object-oriented substation event. So this will be sent as a signal in the network cable. So this is a like physical device. It will be sending the signal in the network cable, fiber optic cable or RJ45 cable. So using this, we will be able to reduce the physical wiring. So if you have any doubt, you can just ask, because we have few more slides. These are all some of the the companies which the central government companies or the state government companies. They combinedly operate the power systems in our in our country, like Power Grid Corporation of India, Central Electricity Authority. Like there are a lot of abbreviations which you can understand. So this is how an operation is performed. So this is basically a SCADA. This is basically a SCADA, and from here we'll be having a numerical relays or digital relays, and this will control the physical equipments in the field. And all the signals, if you receive in the copper cable, it will increase the cost and the complexity. But if you receive this as a software signals, we are reducing the complexity in the digital substation. But these equipments will be still present in the digital substation. The only the area which we have digitalized this part. So these are all the major standards which we use. Mostly, if you refer this IEC 61850, this is the major standard which you can see for most of the equipments. We use this 61850 standard. So we have come to an end. So if you have any doubts, you can just ask. Otherwise, we can wind up the session.
Participants, if you have any doubts, you can ask. Either you can unmute yourself and ask your doubt, or else you can post your questions in chat. Any questions from participants? Sir, on behalf of our management, our principal, our HODs, I would like to extend my heartfelt thanks for accepting our invitation and delivering the lecture, sir. The session was highly informative and we come to know many aspects on digital substation, and I'm sure the participants would have been highly benefited. Thank you once again for accepting our invitation and delivering the lecture. Thank you so much, sir.
Thank you very much, sir. Thank you for giving me opportunity to share my little knowledge, and thank you all participants and faculties and the management. Thank you, sir.
It's a pleasure, sir.
Thank you, sir.
Participants, I request everyone to turn on your camera so that we can take a group photograph. So it is mandatory to submit group photograph to AICTE. So I request everyone to turn on your cameras so that we can have a group photograph. Thank you. Thank you very much. So we are almost nearing the end of our FDP. I once again want to insist that the last session will be at 1:30 p.m. That is assessment and feedback. So kindly everyone join for assessment and feedback, and it is mandatory to obtain 60% marks in assessment for obtaining the certificate. And before that, we are having one more session at 10:45. Mr. Dijo will be handling the session. So stay online. We'll be having a break of 15 minutes and we'll be starting the session at 10:45. Thank you.